Okay, well we've got a symmetric group, and I'm going to give you another way of writing it. Just take an element like that. This is all very well. It tells you what's going on, but it doesn't give you any structure. It doesn't give you any insight into what's actually going on. It's a little bit difficult to see what's happening here. So I'm going to write this in what's called cycle notation, which turns out to be very, very, very much more convenient for doing lots of things. And in fact, come to think of it, once you start with cycle notation, you forget about this. You write it like this. You start with a 1. 1 goes to 4. 4 goes back to 1 again, so it sort of closes the loop and we close the bracket. 2 goes to itself, look. 3 goes to 5. 5 goes to 6. 6 goes back to 3 again, so we close the bracket. That's not a very good example, is it? Okay, well we've got a nice group here, and I'm going to consider an element of S7. 4, 5, 6, 7. 4, 1, 7, 5, 2, 6, 3. 5, 2, 6, 3. So on the bottom we've got 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to consider a new way of representing this, because this way is all very well to write it. It's very explicit. So f of 3 equals 7 and f of 6 equals 6 and so on. But we don't get any insight into how it operates. So I'm going to write it in this thing called cycle notation, which turns out to be a much, much better notation. In fact, once you've learned cycle notation, you forget about this way of doing it. So how do we do it? Well, we open a bracket and we write a 1 down. And then we observe that 1 goes to 4, so we put 4 there. What does 4 do? 4 goes to 5. What does 5 do? 5 goes to 2. What does 2 do? 2 goes back to 1. So we don't write a 1 here, we just close the bracket, and then we cycle 1 to 4, 4 to 5, 5 to 2, and 2 back to 1 again. So it's called a 4 cycle because it's got 4 elements. Now, what's the first number that we missed? We've got a 1, we've got a 2, we need a 3. What happens to 3? 3 goes to 7. 7 goes back to 3 again. So we just close that. 1, 2, 3, 4, 5, 6. Well, 6 goes to 6, so we close straight away. So this thing here is called a 4 cycle. This thing here is called a 2 cycle. And this, I guess, is called a 1 cycle. 1 cycle. But you kind of, no, that's kind of stupid. You don't really need this. So you just write it down as 1, 4, 5, 2, 3, 7. Now, what happens if you want to combine this with another element of S7, combined with, I'll put this in some kind of square brackets. There we go, and I'll just make one up. 1, 3, 5, 2, 6, let's say. Well, what do we get? In cycle notation, let's have a look at it. 1 goes to 4, and 4's not touched here. So 1 goes to 4, and 4's not touched there. 4 goes to 5, and 5 goes back to 1. So that's closed. What do we start? We start with a 2. 2 goes to 1, and 1 goes to 3. 3 goes to 7, and 7's not touched here. And 7 goes to 3. 3 goes to 5. 5 goes to 2. 2 goes to 6. 6 goes back to 2 again. There we go. So we've got this nice way of representing them. You've just got to think about how they represent. So I'm just going to define a cycle. Well, actually I won't. I'll stop here and I'll define a cycle on the next screencast. So I'm just going to stop there. That's the cycle notation, and this is how to multiply two cycles.